Okay, so I did section 7.2, number 51. Yeah. Um, so it asked for, well, the problem was the accompanying figure shows the dimensions of a small light bulb at 10 equally spaced points. So the picture was a light bulb shape in two dimensions, and it started on the origin and went out, extended to 5 centimeters, and it had 10 equal intervals, so the intervals were half a centimeter. Um, its basic shape was a circle attached to a rectangle, which in 3D is a sphere attached to a cylinder. Yeah, so part A asks to use the formulas from geometry to make a rough estimate of the volume enclosed by the glass portion of the bulb. So, to make a rough estimate, what I did was I used the sphere volume formula right here. And looking at the graph, it was pretty easy to tell that the radius of this sphere was 1.25 centimeters. So I plugged 1.25 centimeters in for the radius. And the volume I got was 2.6 pi centimeters cubed. So this is for the sphere part. Um, Now I have to find the volume for the cylinder. So I used the formula to find the volume of a cylinder, and that is pi times radius squared times the height of the cylinder. And since the the radius for this part is thinner when you look at the graph, and it was only 0.625 centimeters. The height of the cylinder was 2.5 centimeters, and so I plugged these in and I got the volume for the cylinder to be 0.977 pi centimeters cubed. So to find the total volume, I added up the volume of the sphere and the volume of the cylinder, and I got approximately 11.23 centimeters cubed. Alright, now part B says use the average of left and right endpoint approximations to approximate the value. So I said that the left-hand approximation is from the left. So what you do is you go to the leftmost interval, which on this case would be 0 to 0.5, and you go up from the x 0 until you hit the line of the function, which happens to be 0, and you go right. So that means that the area for the first part, for the first interval, 0 to 0.5, was 0. So that was kind of an example. And so what I did was I broke up the shape into 10 intervals, and I used the approximation method, which turned the intervals into 10 different size cylinders, all with the same height. They had the same height because the intervals were equal. Yeah. So here is the massive formula that I used to do the left-hand approximation. And so right here, you can see my first example that I tried explaining. Here is the second interval, and it goes from 0.5 to 1 centimeters. And so for this one, the I went up from 0.5, and I hit the line that was going like this, and then I went straight across. And the height of this straight across line right here was 2 centimeters. And so, yeah. No, it was 1 centimeter. Yeah, it was 1 centimeter. So then I squared it because that's what the volume formula asked for. Yeah, and then I did this for the rest of the intervals, and I multiplied it by pi because it's rotating over the x-axis. And so I calculated this to be 11.15 cubic centimeters. So that's the left hand approximation. Yeah, okay, so now I have to do the same thing except using the right hand approximation. So that goes off the same principle about the left hand approximation, except instead you go to the right, not the left. So, for example, if you have an interval that starts here and goes to here, then you go up from here until you reach the function of the line, or that. Then you go to the left. So, yep, that's what you do. So I took all those right-hand approximation integrals over the 10 different intervals and multiplied them by pi, and I got for the total volume to be 11.76 cubic centimeters. Yeah, and so now I have to find the average of the volumes approximation things, so I added them up and I divided by 2 and I got 11.45 centimeters cubed. And that is the question that I had to answer. Yep.